Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we're going to discuss bottom-up versus top-down algorithms. At a very basic level, all it means is a bottom-up algorithm is an iterative algorithm, and a top-down algorithm is a recursive algorithm. But let's see what this actually means. So let's use Fibonacci to discuss bottom-up versus top-down. In a very basic and simple example, we can say that the bottom-up approach takes your smallest values, and using these smallest values, we can calculate any number in the Fibonacci sequence. So we start at the bottom, and then we run a loop, and each step we add one item to it, and we can build up our solution until we reach the nth Fibonacci number. With top-down, we use recursion. So we express the nth Fibonacci number as a recursive call. So we start with the number we want, we start with n, and then we recursively go backwards or from the top down until we reach the base case. Then once we have the base case, we can build up these numbers that we know into the solution that we want. So starting at the smallest number, or the bottom for bottom up, and then going to n, we're starting at n, the top, and going down to the base case for top down. So with the bottom up or iterative approach, we start with the smallest numbers that we know, and then we build up off of these, adding one step each time until we're able to calculate the solution that we want. So for Fibonacci, we start with 0 and 1, and then you start your loop, and this will usually be a for loop or a while loop with the bottom-up approach. Then you continue to sum items together until you calculate the nth Fibonacci number. So to visualize this, we know the first two numbers in the Fibonacci sequence are 0 and 1. Then we sum those together and we get 1. Then we sum the previous two together and get 2. Then we sum the next two together and get 3. And we continue to add these numbers, and we can calculate any number we want just by starting with those bottom values. For the top-down or recursive approach, we know how to express the value we want as a combination of problems or combination of recursive calls. So we know the nth Fibonacci number is just the sum of the two Fibonacci numbers before it. So Fibonacci of the n is equal to fib minus 1 and fib minus 2. And we don't immediately know what these are, but we do know what the base case is. We know the first two numbers in the Fibonacci sequence, and that's the key to a recursive function. So let's see how we calculate an answer from the top down. We know how to express a Fibonacci number as being the sum of the previous two Fibonacci numbers. So in this case, if we wanted to calculate the sixth Fibonacci number, we can do it top down, and what would happen is these recursive calls just keep building backwards. So we don't know the answer we want, Fibonacci the sixth, and we don't know any of the ones that come before it until we hit our base case. So we start to call this function backwards, but then we hit the base case, and using these numbers that we know, we can then build up in the other direction, which will then eventually calculate the answer that we want. So we get 1 plus 0 is 1, and then 1 plus 1 is 2, 3, 5, and then we eventually calculate 8. So we got to this number by just expressing our Fibonacci number as a combination of subproblems. Then, once we calculate down to the base case, we can combine these subproblems to get the answer that we want. So it's called top-down because you express the solution that you want as the final state. For example, to calculate the sixth Fibonacci item, we pass in the number 6. So we start with our top, then we recursively calculate it until we hit that base case and then build up the solutions. So let's compare bottom up versus top down. Bottom up is typically preferred because we don't have the implications of the call stack. With a top-down algorithm, you add space to the stack every function call you call recursively. This can lead to things like a stack overflow and adding additional space complexity. However, if your language has tail call optimization, this isn't a concern. Both bottom-up and top-down can be used in dynamic programming, and when you do use it in dynamic programming, that means you have overlapping subproblems, and you should be using memoization. Thanks everyone, and I'll see you in the next lesson.